Hi, my name is Carrie. I'm a student nurse in the nursing program at Anoka Ramsey Community College. I am in my first semester of nursing. I've been going to the college now for a little over a year. And yeah, I have about 2 more semesters to go, so a year from now I should almost be graduated, which will be great. I can't wait. But anywho, so today I'm going to talk about how the COVID-19 virus attacks human cells and then also how the virus vaccine works. And I actually just got the vaccine, the first dose, um, like 2 hours ago. So we'll see how that goes. Hopefully no side effects. But first up, I'm going to talk about how the virus has affected me personally. We'll talk about right away, like my grandpa did get the virus, and he was in a nursing home, so it spread pretty quickly in there. He did get the virus, then I think it was like the 15th day after he got it, he tested not positive anymore, but then unfortunately did pass away. They're saying complications, I think it was, which, I mean, the virus pretty much is what ended him. Besides that, that was hard. But like school-wise, it's not fun going to school in a pandemic. Definitely not. I was in my first year of generals last year when the virus really hit America hard. Went to spring break and then just never came back. But I mean, it has its benefits of going to school. Online, you don't have to get up at, if you have class at 8 a.m., you don't have to get there to actual school. You can wake up at 7:30 and still make it to class on time. But besides that, I think the workload of homework has definitely gone up since going online. It's a lot more projects and group stuff, and it's harder to communicate with each other, like classmates, to do projects instead of doing it in person where you can actually look at somebody and speak to them. So, I mean, that sucks. The communication is definitely going down, which I think is going to be a big problem in the future for anybody, like kids growing up and stuff. I think communication is going to be lost because of this. But I will start talking about the actual virus here. So the way it attacks like the human cell, the virus's main goal is to, like the main goal of all viruses is to thrive and infect as many host cells as possible because this ensures its survival. So that's the general goal of a virus. But so more talk about COVID. The reason why COVID is so dangerous is because there's so many routes of transmission, through respiratory, kidneys, GI. There's one more, but I can't think of it right now. But so what the COVID virus does, it seeks out like a specific molecular target to gain access to our cells. And this molecular target is called the ACE2, which stands for angiotensin converting enzyme 2. Angiotensin, yeah. So I do have a picture here. So yeah, these are the ACE2, and then this is obviously the COVID cell. I'm sure you've seen that before. But so like we know that COVID affects people differently, ranging from no symptoms to killing the person. And this is because of the cell setup and the number of the ACE2 proteins in the body. Other factors affecting your symptoms of the virus are depending on the initial load of the virus. If you don't get a lot into your body, it's easier for your body to fight off. But if you get like a huge load, it's going to be more work for your immune system. And also the number, like I said, the number and makeup of the ACE2 proteins, and then the integrity of your immune system. So the virus gains entry into your cytoplasm of your cell, and then from there it pretty much hijacks your ribosome protein making synthesis, and it uploads like its DNA into the system, and then your cells become like a factory and they pretty much reproduce the virus and just keep shipping it out. And it makes copies of itself, and then from there your immune it leaves the cell, and then it goes to other cells to infect that cell, and it moves throughout your body. Um, besides that, so if your immune system isn't strong enough to kill the antibody, then the virus will obviously travel and infect other cells. And then from there, it like restarts the process, and it's just like a giant loop system. But um, if you have a good immune system, what it happens is your helper T cells, they actually, when the virus cell leaves your cell, and the helper T cells like recognize it as like a threat, and they engulf it, and right after that they make antibodies that'll fight against the virus. That could be why some people are asymptomatic, is because like their immune system has the good antibodies that kill off the virus before they're even infected. But like I said, if you get like a full load of the virus and you don't have a good immune system, then obviously you're going to be symptomatic because the virus is going to spread. They have also found in the lungs and the GI tract. Oh, I'm sorry. The ACE and ACE2 protein cells are found in the lungs, GI tract, kidney, and the blood vessels. And this is why we see respiratory and GI problems with COVID, along with like renal failure and some cognitive problems that can be like dementia. So that's pretty much it for how it affects the host. But now I'll talk about the vaccine itself. Like I said, I got that today. So it's an mRNA vaccine. And these vaccines don't take as long as regular vaccines to be developed. So that was good for us. But the point of the vaccine is to help your immune system and show your immune system how to recognize and fight off the infection before the actual infection even occurs. So yeah, you train your immune system to recognize the spikes on the COVID cell. And like I'm sure you already know, like these spikes. So it's going to train it to actually see those spikes. And then it also has your body produce its own set of spikes that are just exactly the COVID spikes. How they did that, researchers took the RNA from the virus and then isolated the part on the gene code that gave instructions on for the virus to build its spikes. So we took that and isolated it, and then figured out how to make the spikes from the virus, but not the whole virus, just the spikes. So then when you get the vaccine, then your cells then like take that copy and they produce their own spikes, and this is in like a large volume. And then your immune system obviously recognizes this, goes into action to fight off the intruders. And you won't actually get sick, like it's not a live virus, live vaccine. So you won't actually get sick, but your immune system just takes a while to recognize the spikes. And then after it breaks down the spikes and the mRNA, it produces memory cells for the future use against this virus. And so if you would get the virus again, your memory cells will recognize that and release the right antibodies to prevent the infection before it actually happens. And like these memory cells, I think, can stay in your body for like months and or years. So I mean, that's why sometimes you have to get boosters. But besides that, I think I'm not a COVID genius. I don't know any more than that. But thank you for taking the time to watch this. Goodbye.